Hello, welcome to a video on Lavender 17 sample problems from the College Board. This is multiple choice non-calculator. So we're going to go over all 17 of these problems right now in this video. I'm going to kind of go through it quickly, and of course you can always fast forward to any problem that you need to see. So for number one, hopefully you recognize that's the limit definition of a derivative, where the original function is going to be cosine x. So of course, the derivative of cosine x, we would know is negative sine x. And since we have to evaluate this at 3 pi over 2, I'm doing f prime 3 pi over 2, which is going to be negative sine 3 pi over 2. 3 pi over 2, or sine of 3 pi over 2 is negative 1. So you're doing negative negative 1, which makes that positive 1. So the answer is A for number 1. Okay, number 2, you want the derivative and the second derivative to be negative. So clearly you want your function to be decreasing, because the original function is shown to the right, since that's y right there. And then you want this to be concave down. That only occurs at point B. It's increasing at point A, definitely decreasing at point C, but it's concave up, and concave up on D and E as well. So we're going to go B for number 2. For number 3, this is going to require some pretty gnarly implicit differentiation. So we're going to do product rule twice for y cubed x and y squared x squared. So brace yourself for this one. I take the derivative of y cubed, which is 3y squared, but times dy over dx, and of course times x, plus, then I leave y cubed alone, take the derivative of x, which is 1. So that's just the first pair. Then for y squared x squared, take the derivative of y squared, which is 2y times dy dx, of course times x squared, because you can leave the second function intact. Then plus y squared times 2x, just 2x, because that's the derivative of x squared. And of course, to the right side is 0. So we want to collect the terms of dy over dx. So 3y squared x times dy dx plus 2y x squared times dy dx equals negative y cubed minus y squared 2x. Factor out dy over dx, 3y squared x plus 2yx squared equals all that junk on the right side. And then divide everything by that expression. So negative y cubed minus 2xy squared, 3x y squared plus 2x squared y. So pretty nasty here. But then you could plug in all the stuff that we know. 1 for y, so you get negative 1, minus 2 times 1, all over 3 times 2 times 1 plus 2 times 4 times 1, you get negative 5 over 14. So that's C. So you can see the first two problems I did pretty quickly, but number 3 took a little while. My suggestion on the real thing is that something like number 3, guess something, come back to it later, because you don't want to burn yourself on time, because you're going to need about 3 minutes, good 3 minutes at least, to do this one. But 1 and 2, we could probably do it under a minute. So, and you get an average of 2 minutes per question, so you are going to have to be somewhat strategic with how you spend your time. Now let's look at 4, 5, 6. 4 is definitely a washer problem. The reason why is that, first we have y equals 3. That's what we're revolving around. So that's our axis of rotation. And 2x and x cubed, they're going to intersect, be semi-equal to each other. The 2's will cancel. So 1 equals x squared. So they intersect at 1 and negative 1. But since we're only doing this in the first quadrant, and even type from 0 to 1, so that's where we're going to intersect. And of course, y equals 2x is going to look kind of like this, whereas y equals 2x cubed would be a bit more like that. You don't have a calculator, but if you think about it, if you're putting like 1/2 for x, you get 2 times 1/8. That's less than 2 times 1/2, which is 1. So hopefully you can see, and plus if you were to take the second derivative of 2x cubed, it would be concave up. Hopefully that helps. This region is getting revolved around y equals 3, creating a washer. So we know from 0 to 1, eliminate d and e. And we suspect it's a washer, eliminate c. So it's down to a or b. And by the way, there's some typos there. That should be 2x cubed there, and that's also 2x cubed. Sorry about that. So the outer radius, here's the center, here's the inner, here's the outer. So our washers are going to look kind of like that. So our outer radius is simply going to be 3 minus the bottom function, which is 2x cubed. And our inner radius is going to be 3 minus 2x. So we know the answer is going to have to be a. So you can kind of go through that kind of quickly if you have a strong understanding of the concept of volume of revolution. 5 and 6. So looking at the choices, they're talking about extrema and points of inflection. The trigger there is that we're going to have to use derivatives. So f prime of x, now I'm going to separate that from number 6 here so it's not confusing. F prime of x is going to be 4x cubed minus 6x squared. And f del prime of x, of course, is going to be 12x squared minus 12x. So we're going to have to solve for points of inflection and relative extrema to see how many we have. Like number 3, this could take a while, so you may want to skip and come back to it later on the real thing. But if I solve for my second derivative, because that's going to be kind of easy. So 0 and 1. And if you do a sign chart, because points of inflection is when the second derivative changes sign. So POI, second derivative changes sign. Very, very important. We don't want to mess that up. So anything greater than 1, second derivative is positive. Like you plug in 2 into your second derivatives, it's positive, negative, positive, so it alternates. Definitely we have 2 points of inflection. So A is no good for us, nor is B. And C, D, E. The fact that we see that option show up 3 times kind of tells me I'm kind of doing this right. So now we have to narrow it down by looking at the first derivative. So if I factor for my first derivative, if I factor out 2x squared, that's 2x minus 3. Those are your zeros for the first derivative. And it's definitely positive here and negative, but it doesn't change sign at x equals 0 because it's x squared. So there's only one extrema, actually, just at 3 halves. So that's why the answer is C. See, that kind of takes a little bit longer. But 6 we can move through pretty quickly. This is going to be a repeated chain. F prime x is going to be 2 sine 3 minus x times the derivative sign, of course, which you know is cosine 3 minus x, times derivative 3 minus x, which is negative 1. Plug in 0, you should get B. Okay, trucking along here. 7 is going to involve a differential equation. Fortunately, this doesn't have any ln's, so y times dy, 4x times dx, y squared over 2 when you integrate, 4x squared over 2 when you integrate, plus c. I know that we're going to have to do square rooting to get y by itself. So a and b are out. Solve for c, so you're going to have to use your initial condition here. Plug in -2 for y. Remember, don't start isolating y yet. You got to solve for c first. Very, very important. So that's 2 on the left side. That's 8. C is going to be -6. So y squared over 2 equals 2x squared if I reduce that, minus 6. Multiply both sides by 2. Okay, now we're in business. You know it's not going to be e. and y is going to be plus or minus the square root of 4x squared minus 12. Because y is negative, initial condition, we're going to want the negative counterpart, so we're going to go C. The domain is x greater than root 3 because you can't square root negative numbers. If you set the bottom, or sorry, not the bottom, the inside of the radical greater than 0, that's what you get. Average rate of change, not average value, just average rate of change, simply going to be f of 3 minus f of 0 over 3 minus 0. Again, you don't get a calculator, but you guys can handle it. F of 0 is 0, f of 3 is going to be 81 minus 15 over 3, 6 over 3, that's 22. So you get C for number 8. For number 9, you're doing with speed, or actually, sorry, you want to know when it's increasing. So when speed is increasing, that's a concept that some of you guys had a little trouble with in our last test. Velocity and acceleration will be the same sign. Because think about it, if you're moving to the right and acceleration is moving to the right, that's going to push you faster to the right. Or if you're moving to the left and acceleration is also pointing towards the left, that's going to be faster going to the left. So you have to be the same sign. They're the opposite sign to counteract each other and they slow down, or the particle or whatever slows down. So we need this to be the same sign. Like number 5, this is going to take a little while because we have to do a first derivative, second derivative, and do a sign chart. So this is something you may want to come back later to do. So you can have to be, again, selective with what you choose to do in the beginning. S prime t is 6t squared minus 48t plus 90. Factor out of 6. T squared minus 8t plus 15. Keep breaking it down. So we see that our derivatives will be positive, negative, positive in those intervals. Then for the second derivative, that's going to be 12t minus 48. Factor out 12. So that's acceleration, right? It's positive and greater than 4, negative and less than 4. So definitely if we look at the choices, when t is greater than 5, of course they're both the same sign. So I kind of like that. So I'm going to get rid of A and B. And if I keep looking at it a little more closely, if we're between 3 and 4, in that kind of area right here, you know, velocity and acceleration are both negative, so that's also going to be increasing speed. So the answer is E. Okay, 10 and 11. What's happening here? Probably best to convert the root x to x to the 1/2 power. Strongly recommend you do that. We've done that before. So if you have parentheses x minus 1 times x to the 1/2 power times the x, and you distribute, you have x to the 3/2 minus x to the 1/2 times dx. And you increase the exponent by 1 and divide by a new exponent. Remember, this is how we anti-derive. Don't forget about your plus c. So it's 2/5 x to the 5/2 minus 2/3 x to the 3/2 plus c. So we got D as in dog. Again, that's kind of one you want to get through quickly. Because you have a limit of x approaching infinity, we're looking at the degrees. -1/4. Boom. Move on. Don't want to take too long. Okay. Oh, that's very interesting. It says here, Microsoft OneNote's weird, saying oxen sex. That's kind of strange. I don't know why it's saying that. Anyway, let's keep moving. Okay, for number 12. So right now, we're going to have okay, so for number 12, we have 2 graphs here. Y equals 5x minus x squared and y equals 2x. We're trying to find the area of the shaded region. Like that's an easy one. Of course, that's the top curve, and the line is right there. So we know which one's the top one. So, and also we have to see where they intersect, because it's not told to us. So you kind of just move things around. Background x, easy. They intersect at 0 and 3. So we're going to integrate from 0 to 3. Top function is 5x minus x squared. Bottom function is 2x. We're going to work this out. Yeah, clean it up. Negative x squared plus 3x. Anti-derive, super easy. Plug in 0 and 3. Don't forget about the 0, don't waste your time with it. Negative 27 over 3 plus 27 over 2. That's going to be 4.5. Okay, 13. Looking at the choices, which of the following, we've talked about this, consider process elimination when you see that. That will be kind of a trigger as what you need to do. Notice that all the choices have derivatives, so we should do a derivative, right? Well, what happens when I do a derivative of that? The derivative of 5 is 0. Right? So I derivative, antiderivative, knock each other out, so you get e negative t squared. But because you have the 2x, oops, sorry, you got to put in 2x in for t. And also got to take the derivative of 2x. This is kind of a chain rule. So it's e negative 4x squared times 2. So that's going to be either d or e. Then if we kind of look at these two choices, if I plug in 1 in for x, that becomes 2, and that, of course, just wipes away when you integrate from 2 to 2, leaving with y equals 5. So the answer is definitely e. 14. Slope fields, which I haven't seen in a while. Again, which of the following? Process of elimination. So when x is 0, clear our derivative is 0. And when y is 0, our derivative is undefined. And of course, when x and y are both positive, so sorry, it's x or y. I think I said negative x or y, but it's just x or y. Of course, when x and y are both positive, we want our slope fields to be positive, and both negative, still positive. So it kind of looks pretty good over here. And of course, when x is negative, y is positive, vice versa. Yeah, and then kind of see how they're kind of flat along the x-axis, which is when, sorry, kind of flat along the y-axis, which is when x is 0, and kind of more vertical on the x-axis when y is 0. So let's see. Okay, then we're at the home stretch. Uh, 15 is something we haven't done before. I'm not sure if you'll really see it, but it's a pretty simple concept. Simply the way this works is that you have a circular city, and apparently they're going to live on the outer rim, so it seems. So this is what population density is kind of saying. They're kind of telling you find the population in that rim, because you're living around a lake, right? And it's a circular lake, and the people are not going to live on the lake, or they would drown unless they have a house built on the lake, which I guess you could have. I don't know. So the way this is going to work, f of r is the number of people, and if we take the circumference and times the thickness of the circle, or we treat it like an integral, where we go from 0 to 1, factor out the 2 pi, or pull the 2 pi out, r times f of r times dr. In this case, we get a. So we may have to talk a little more about this later in class, but that's we won't have that on our final. Don't worry about it. But yeah, that's how that works. that's just, of course, f of x. But because you have x squared, it's f of x squared times 2x using chain rule. So that's going to be a. That's just FTC. I don't know if you're in a calculus right there. Okay, last one. Separate, integrate, kind of rhymes. Substitute. So C is 5. And cube root. And so it's E. Okay, so that concludes the video for the semi scale problems. And you can see I did it in about 20 minutes or so. But of course, taking time to explain it, I could probably do a little faster if I wanted to. You probably should spend about 34, 35 minutes on your own doing that. So anyway, we're all set.